general relativity step by step. I've been a little bit coy about why I've written the index here as a superscript and the index down here as a subscript, and now I'm going to show you why. It was with all of these things, it's just a notation, so it's just a very, very good one. So let's just write out this Vi equals sigma over j Vj bar di xi by di x bar j. There it is. Now what Einstein noticed, I mean the legend says that it was Einstein's wife who noticed when she was typing up the manuscript, I don't know if that's true or not. She noticed that a repeated index, in this case j, a repeated index is summed. And there's a little bit more to it than that. There's a j and a j there. And so if you repeat that index, write it twice, then it's summed over j. So the Einstein summation convention is to say that summation over a repeated index is assumed or understood. Equals, you do not need to write the sum. So with this rule here, I can write that equally as Vi equals Vj bar di xi di x bar j, with an implicit sum, which you do not need to write down because of the Einstein summation convention. There's just another little, not corollary, there's a little rider on this, which is that when you have a repeated index, you've got to have one in the up position and one in the down position. So, and it counts as a down position because it's on the denominator. So I've got Vi equals Vj bar di xi by di x bar j. That's a superscript and that's a subscript. You always sum a superscript with a subscript. Let's have a look at the gradient transformations for Gi, and that equals sigma over j Gj bar di x bar j by di xi. And again, we've got a j and another j, so I can just notationally just get rid of that. And that's, again, an implicit sum. So I'll give you lots of examples of this as we go by. Let me just show you how I think about these, how I write them out. I've got Vi equals V bar something, which I'll fill in, di by di x something something. So how do I fill in the blanks? Well, it's got to be a superscript. We've got to maintain the position of the diacritics. So that's an I. That's got to be a J. It can't be an I because it's this complex matrix, this complicated matrix multiplication. There's that J, and that J's got to be summed over something. That J can't be summed, that's a superscript, so it's got to be summed on something downstairs, which is J there. That J is associated with the barred coordinate system, so that X must be an X bar. And now we need to tell the right-hand side that we've got this I index here, which is in the up position, so that must be I. So that I is equal to that I there, and you can just read it off. You can just read off that I from both those positions. Let's do the covariant. Gi equals G bar times di x. So I've just written the skeleton in there, so how do I fill the rest of it in? That can't be an I. If that was an I, that would just be crazy, because we need to involve, you'll remember that when we did the h and theta example, the h and the thetas affected both the h and the thetas affected the x and the y, and both x and y affected theta, and everything affects everything else. So that must be a j. We've got an implicit summation, which I'll get rid of at the end. This is a j in a barred coordinate system, and the j is downstairs, so it must sum with a j upstairs, which is there. The j is associated with the bar, so the bar must go there. We need to tell the right-hand side which index we're thinking about, and so that index goes there. So that's how I fill it in. Right, I'm going to stop there.